Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called There's Something in the Shadows by Sudoku and Chinstrap. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, or aka a box. We have yin yang, where we need to shade some cells, and all shaded cells are orthogonally connected, and so are all unshaded cells. Every 2x2 space contains both shaded and unshaded cells. So as an example, we could use this as an example of shaded and unshaded. So this would be shaded, and the unshaded would be essentially like something like, well, we have it unshaded. And the reason why this, okay, so all shaded cells are orthogonally connected, which means that you must be able to go from any section in the shaded section to any other cell in the shaded section just by going through edges. And you should be able to stay within the shaded region doing that. So this is a valid example of a shaded region. If, however, we did... what's a better example? We don't have anything there. No equivalent. This would not be valid. Because even though the shaded it wouldn't be valid also because this 2x2 space does not contain both shaded and unshaded cells. Actually, we can just do it this way. So while this 2x2 space contains shaded and unshaded cells, this is not orthogonally connected to the rest of the shaded region, right? Because if you try to go from any of these cells to any of these cells, just by going through edges, you would have to go outside a shaded region or shaded cell, right? You would have to go here or something like that. Same with this part, right? So that's the reason, that's what orthogonally connected means, that you should be able to go from any part of any cell in the shaded region to any other cell in the shaded region just by going through edges and stay within the shaded region. And same thing with the unshaded region, right? You should be able to go from any part of the unshaded region to the any other cell in the unshaded region just by staying in the unshaded region and going through edges. Okay. For the yin-yang, we have yin-yang split lines, where yin-yang borders split lines into two or more segments with the same sum. If two cells are adjacent along the line, they are in the same segment if and only if they have the same shading. So these borders, essentially, between the shaded and the unshaded part will basically, how do you say it? They will divide the line or split the line into two or more segments. So every line must be essentially split into two or more segments with the same sum. And digits may not repeat within a segment, and every line contains shaded and unshaded cells. Okay, so that's the clear clarification. Every line will be split into at least two segments. So this would be considered essentially, this segment would be, okay, so if this were the actual shading, this would equal the same as these two, which would equal the same as this, which would equal the same as these two digits. Right, because this is a segment, because they're both unshaded. This would be a shaded segment, Oh, I've just realized something. It doesn't really matter which direction you have shaded and unshaded, right? Because it's just a matter of essentially, yeah. Uh, you could do reverse essentially, and it wouldn't matter, right? So every line. So if this were essentially the way that it would be broken up, this would equal the same as the sum of these two digits, which would equal the sum of this digit, which would be equal to the sum of these two digits, since they are in the same segment because they have the same shading. Similarly, this would equal the same as this, which would equal the same as these two, which would equal the same as that, to make that shading work. And digits may not repeat within a segment, so keep that in mind. And every line is basically has a border along across it. Also, we have segment counters, where a digit in a circle on a line indicates how many total segments that line has. So, for example, this one, actually, let's go look at this one. This would have 1, 2, 3, 4, 5, 6 segments. So this would then be a 6, right? Because this is a segment which would equal the sum of this, which is equal to the sum of this, which is equal to the sum of these three, which would equal the sum of that, which equal the sum of that. Obviously, it doesn't quite work that way, so it doesn't. That's not exactly correct, but this would be 1, 2, and 3. So this would be 3, and this would be 1 and 2, so that would be 2. But this would also be 2, because this would be one segment here and one segment here. So these circles basically indicate how many total segments the line has. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so this is interesting. You cannot have... Well, you could have a border here, but the problem is... That's interesting. So obviously you can have at most 4 segments in a 4-length line. But the problem is you can't have all 4 here, right? Because then all 3 of these would be the exact same value. And we'd have a repeat then. So this is 2 or 3. This has to be 2 or 3 also. Now that's interesting. Which one can actually have 3 though? If this were 3, the problem is 2 of these digits would have to be basically the same. Because if this were 3 and this were another, I guess it could be 3 and 2, 1. Okay, yeah, this can't be the 3. If this were the 3, how would you break it up? You would have to break it up this way and this way, right? Because these two would have to be the same. This would then be 3. This would have to be 3 because it must equal the same sum as this. And this would have to be 1 and 2. But because of the 2, 3 pair, we know this cannot be 1 and 2 in this row. So that does not work. So this cannot be 3. This has to be 2, which forces this to be 3. And this can be broken up. Again, this can't be... the sum cannot add up to 3. So it's either here or here or here, right? So this we have to have 2 digits that are the same. The only 2 digits which can be the same have to be these 2. Therefore, these are broken up that way. So this is a boundary. Okay, so the boundary, we have to do that. So this has to be different than these. So I guess we'll shade this green. These have to be different then. These are different boundaries. Therefore, this is 2, right? Well, 2, if we had the border here, that wouldn't work because 2 would have to equal 3 digits, which is not possible. So the border cannot be here. The border is either here or it's here. So the border is either here or here. This could be 1, 3, and 1, 3 and 4, 5, 6, which means this is 4, 7, 8, 9, 4, 7, 8, 9, and these are the same digit. This is not, these two are the same. So we're not sure which ones they are. This has to be 3 digits added together to add up to 1. So that must mean this is, one of these is 6, 7, 8, or 9. And this must be 1 through 6. 1, 4, 5, 6. This must be the same segment as this. If it's not the same segment here, then these would have to, well, it's not true. You could have a different segment and then this is a different segment. This is 1, 2, 3, 4, 5, 6, 7, possibly. But it can't really be 7 segments because if it's 1, 2, 3, 4, 5, 6, 7, all of these digits are the same and there's too many repeats. What about 6? I don't think 6 is possible, right? If you had 6, you would have to divide at least that way. But then all 3 of these would be the same. It would be the same for that. What about 5? 5? You could divide, this way, then that way, then that way. But, okay, so the problem with 5... Well, first of all, you can't have a yin-yang go just be like that small. So that wouldn't work. Oh, this is an interesting shape here as 4. So obviously this cannot be the same as this one. So either this is a sum of all 3 of these. Yeah, how does this work? You can't have 1, 1, 1, 1 separate digits here because then there'd be repeats and there would be all the same digit. If you try to have 1 here, you could have 3 here. You can't have 1 and 1, so you could be 1, 2. If you tried 1, 2, and 1, these digits would be the same. So that's not allowed. You could have 1 and 3. You could have 2 and 2, though, also. Oh, that's one thing about yin-yang, right? If you have yin-yang, once you have a break, which this has to have a break, you cannot have, so say we try to have this be green and this was blue, right? This blue could not touch the edge of the grid anymore. if this were green also. And the reasoning is because if we try to essentially touch the edge, that would necessarily break the green section into two separate sections. So that's once you've swapped from one to the another, you cannot swap back, right? I'm sorry, you can swap in basically one time each. So from green to blue, then to green back, sorry, blue to green, then from green black to back to blue. And then the rest would be basically blue here, if that's the case. So that's interesting. Okay, that's very interesting. Then that means this segment, well, first of all, it can't be 2. If it's 3, I guess it could be 3, but it cannot break up like this, right? Or like this. So I think that means this is guaranteed. So since this can't be 2, where you could break it up like this, and this would make a valid split line. If you try to do, well, anyways, that wouldn't work because it would have to go something like that. I think this line is forced to basically have a boundary somewhere along here. If you have 3 and you try to not have a boundary go this way or something like that, the only possibility would be here or here. But either way, you'd have 4 unique digits adding up to 1, which is not possible because 4 unique digits add up to a minimum of 1, 2, 3, 4, which adds up to 10, which is not a digit. So I think you have to have you can't have obviously this because then you still have 4 digits adding up. So this must be, first of all, we know this has to be the blue section, and it must continue here. So it must go all the way here. This must be all blue. We have to have some sort of boundary here. So the green, oops, green has to go all the way to here, right? This obviously can't be, it has to be green because you can't have any 2x2 area without unshaded and shaded. Same with this, same with this. This is blue. So what happens here then? Okay, so this is at least 3, 4. Can it be, it can be 4, I think, right? 1, 2, 3, 4, 5, 6, 7. Yep, that's fine. So 1 section, 2 section, 3 section, and 4 is fine. Can you have 5? 1, 2. No, I don't think you can. If you try to have, well, you can't even, yeah. You have to have something breaking this apart. And then 4, I don't know if it works. 1, 2. Yeah, you can't have, okay, you can't have borders crossing like this. That's not possible. So you're going to have a single cut here. And you need at least 3. Actually, no, that's not true. You could do something like that. And that would be 4. 1, 2, 3, 4. Right. But you can't have 5, I don't think. If you have 5, that means you have... It's 7 in length. So that means if you have 5, you have 3 digits, which have to be the same, right? Because there's 3 single segments. 3 segments that are only 1 cell. And these are only in 2 regions, so that's not possible. So So this is a boundary here. Obviously, this cannot be the same as that digit, so this must be part of another segment. So it has to go that way. This one we don't know. This is part of a different segment. Again, if this tried to be a different segment here, the problem is, so if this tried to be green, these two digits would have to be exactly the same because the split line says this segment must equal that segment and it's a single digit. So this must be blue, which means this is green and this is green because of the 2x2 area. So now we have borders here, we have a border here, we have a border here, and a border here. And a border here. Can this be 1? I guess it could be no. If this is 1, well, maybe. This could be 1 here, 1 here, 1, 2, 3, 4. That's possible. So this would be essentially a border going down that way, right? And it would cut that way. That is possible. Actually, no, it's not possible. If this cut this way, the problem is this would be green and this is green. And you can't have a border cut, well... Hold up, yeah, maybe that does work. You could do something like, I guess, like that. Yeah, it's possible. Okay, never mind. Hmm. We don't know if this is the same or different region. This must be the same region as that. Because if this was blue, the problem is these two would be the same digit. So this is green, which means one of these is green, one of these is blue. But if this were green, that would force this to be blue, and these two would be the same digit because you would have this line cut here. So this cannot be blue. This has to be green, which means this is blue here. This is not a boundary here. It's a boundary here and then a boundary here. We have a 2x2 space here. Well, we already knew that, so this was green. This must be the digits 1, 4, 5, 6, 1, 4, 5, 6. So this adds up to at least 7, 8, or 9. It has to have a 1. Because if it didn't have a 1, it would be 2, 4, 5 at least. So this cannot be 1 here. This has to be then 7, 8, or 9 here. So 1 has to be one of these two digits. And it could be with 4, 5, or 6 here. This cannot be 5 unique digits adding up to a single digit. So this must be blue. And since this is blue, in a yin-yang, you cannot have a split going this way and then this way. Yeah, I should have basically explained that here. Say you did have a split going here and then here. The problem is, to connect this blue orthogonally to the rest of the blues, you would have to break the green section into separate sections. Therefore, if you try to have this be green, has a 2 here, a 2 here, it would break the yin-yang rule set. So you know as a shortcut, or as a, I don't remember the term, you have to have 3 of the same digit if you ever have a cross diagonal here. So this must be blue. Since this is blue, and this is a single digit, this cannot be another green here, right? Because then these two digits would be the same. So this has to be blue, which means this goes this way. This is right. This does not have to go boundary. It just basically has to be different here. So this has to be green. which means its boundary does go here. You cannot, one of these is green, one of these is blue. If this is green, this would have to be blue. But then both green and blue would be the same sum, which is not allowed. So this has to be blue, which makes this green. So it blocks there. This is the same digit as that, interestingly enough. This is the same digit as that. This must be the sum of 3 digits that add up to, and it has to be 9. What's the minimum here? It can't be 134 because that would eliminate all possibilities for that cell. So minimum has to be 135. So this must be 9. This is 9. This must be 1, 3, and 5, which eliminates 3 here. So this is 4. Okay, so this is divided into 4 segments. This also then becomes 6, 7, and 8. So this is a 6, 7, and 8 here. It's the same digit as that. This has to be less than this digit, though, so this has to be at least 6. This is 7 or 8. This is 6, then. We have a 6, 7, 8 triplet, actually, in box 3. This can't be 2, so this has to be 1. Can't be 3 adding up with 6 to add up to 9. So this is 1, 6, 7, and 7, 8. This adds up to 7 or 8. So this is at least 3, 4, 5, 6, 7, and it could be 2, 3, 4, 5, 6. This can't be 7 then, because it adds up to at most 7 or 8. This is a boundary, so this must go this way. So the green section is here. This is a boundary. This is the sum of 3 digits. So it's 6, 7, or 8 here. This must contain a 1. That's 1, 2, 3, 4, 5. 1 cannot, no 6. 1 cannot be here. In box 6, we have a 1, 2, 3, 4, 5 quintuplet. So this must be 6, 7, 8 here. Where is 9? 9, this can't be 6 because of the 6 in the box. This has to be 3, 4, 5, and 9. And this can't be 3. And 9 can't be here. 9 cannot be here. So 9 has to be one of these 2 digits here. This can never be 8. Because if this is 8, this has to be 8. But 8 cannot be in the rest of row 3 then, if that's the case. So this has to be 7 or 9, and this is 4 or 6. This contains one of 4, 5, or 6 also. So the rest of this cannot be 4, 5, or 6. It must be 7, 8, or 9 here. 6 is one of these 2 digits. 1 has to be one of these 2. 1 has to be here. This can't be 1. This can't be 4. We have a 2, 3, 4, 5 quadruplet in column 8, which eliminates 2, 3, 4, 5 in the rest of the column. So this is 6, 7, 8, 6, 7, 8. That leaves this as 1, 2, 3, 5. To add up to 7 at least, you need a digit from 4 or 5. So, right, because it must be either 2, 5 or 3, 4 to add up to 7. If it's 8, it's 3, 5. So this can never be 4 or 5 here. Hmm. Let's see. If this is 7 here, that would mean this is 4. This has to be 5. So the 7 here would eliminate 7 here. This would have to be 8, but then this is 5 already because this is 4, and that would not work, right? Because this is at most 3 and 4 added together. Oh wait, this could be 6. Yeah, I messed up. My apologies. No, this can't be 6 because it's 3 and 6. The 6, if it had to be, it had to be here. Right, no, so that actually does work. That's correct. Right, because yeah, you can't. The only way this would add up to 8 is if this was 2 and that's 6, but we know the 6 has to be here because of the 1, 3, 5 triplet. And this is the same as that, and this must add, these two must add up to this digit. So therefore this is 1, because there's no other way that a digit without a 2 could add up from 6 to 7 to add up to 7 to 8. So this has to be 1 with 6 or 7 to add up to 7 or 8. Since this is 7 or 8, if we try to have this as 7, this is 4, this becomes 8, this becomes 5, and this would be at most adding up to 3, 4. So that would already be a contradiction. So this cannot be 7, this has to be 9. So this is 9, this is 9. This has to be 6 then, which eliminates 6 here. This can't be 9. Obviously, this can't be 9. So this has to be a 9 here. This can't be 9 anymore again. This is a boundary. This must be blue because of the same reasoning we had for this area. This could be 1, 2, 3. Well, 3, 4, 5, I think. Can it be more than 5? We have well, okay, can't be 2 because this is too many digits to be just 2. Maybe 3. It's 1, 2, 3, 4, 5, 6. No, it can't be 3. It's at least 4. So 4 to 5. Maybe 6? I'm not sure. So 1, 2. Hmm. So either this is 6 and that's 7, or this is 7 and that's 8. Either way, this can never be 7. This is 6 or 8. If this is 8, that makes this is 3, 5. Which makes this 4, which makes this 1, 5, which makes this 8. Okay. If this is 7, this is 6, this is 8, which makes this 7. So this is 1, 4, which would force this to be 5, which would mean this is 3, 4. Right, to add up to, so again, if this is 8, that means this is 3 and 5 add together. That makes this 4, which makes this 1, 5, which makes that 8. Otherwise, this is 7, which means this has to be 6, this is 8, which means this is 7. So this is 1, 4, this is 5, and this must be 3, 4 added together. So this can never have a 2. This always has a 3, which eliminates 3 in the rest of the column. Therefore, this is a 2. This cannot be 2 here because of the 2 on this segment. So 8 has to be one of these 2 digits here. We're not sure which, though. Okay. Can this be 6 or something? 1, 2, 3. Well, it can't swap here and then swap here. So either this is 3 or this is 2 and then this is 2. I think, yeah, this has to be essentially the same. No, that's not true. It could be 3, then swap, or 2 and then 2. Huh. So if it goes 2 here, 2 here, it would have to go at least 2 here, 2 here. If it goes 3 here and 1 here, it could go 1 here and then 3 here. So 1, 2. I'm looking at the most this could be, essentially. 1, 2, 3, 4, 5. 1, 2, 3, because it cannot be the same digit here and then be completely different here. 4, 5. Right, because you have to split this up as 1 and 3 or 2 and 2. You cannot have 1, 2, and 1 here split up because there would then be a duplicate in the same box. One must be one of these 3 digits here. 9 is one of these 3 digits here. Oh, that's interesting. 9 can't be here or here, so 9 is one of those 4. 9 cannot be here, so 9 has to be one of these 3 digits here. Because if 9 were here, this 9 and another digit would have to add to another digit, which is not possible. Okay. It could be 4, right? 1, 2, 3, 1, 2, 1, 2, 3. That's perfectly valid. Or 1, 2, 3, 1, 2, 3, 1, 2. It can never add up to more than 4 digits, though. So, or more than 3 digits, right? 4 or more, essentially. Um. This has to be green because we have this area being that way. And since this is green, this has to be blue because we have a 2 by 2 area, which is all green. So this green has to go out this way. So the green has to go out this way. This blue must be connected because of the yin-yang aspect. This is 3 blues, so this can't be blue. This is green. This is a separate region. Okay, so one thing we know is this can't be all blue here, right? If this were all blue, this would be 3 digits adding up, and you would have to have a 2. Actually, can we even have 2 here? If we have 3 digits here, we have to have 3 other segments within 4 digits here, and therefore there would have to be a repeat here. If this is 2 digits here, in this 5-cell region, there would have to be 3 regions, which is possible, I guess. So this would be blue, green, 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 green. That's the only way that would work. You cannot have one region that has 1 digit, 1 cell, and another region that has 1 cell. So it'd be 2, 2, and 1. So either way, this has to be green, right? Because it can't switch back. So you can't have 3 blues here. So this could be blue or green. We're not sure which, but this is always green. So these are always green. But if you had blue, blue here, the problem is this would be green, green. And then one of these would have to have a single cell add up to it, which is not possible because it's 4 and 6 at minimum, which is 10. So this cannot be blue. This is green. Since this is green, this is a 2 by 2 area with all greens now. We need a blue. So this is blue, which makes this blue to connect, because otherwise this cross boundary would make a problem. So this is a boundary, this is a boundary, this has to be a boundary then, because it can't have 4 digits adding up to 6, 7, or 8. It's 4, so this can't be 6. It has to have, it's either 1, 2, or it's 1, 3 here. Either way, there's a 1, so this cannot be 1 here. This can't be 1, because we know one of these is a 1. So one of these 2 is a 1 here, and one of these 3 is a 1 here. So this must add up to 7 or 8. This is 3 digits. Therefore, and this cannot be by itself because it would be the same digit here. So this must be green, which forces this to be blue. So this is the cutoff. This is then the same digit as that. So this is 7 or 8. This must be less than 7 or 8. It cannot contain a 1. So it's at least 2 through 5 or 6. This can't be 4, though, because of this 4. So we know 1 is here. If this is 1, 2, and 4, this would have to be 3 and 4, right? If this is 1, 2, 4, this is 7, 7. This has to be 3 and 4 because you can't have 1, 6 or 2, 5. So it would be 3 and 4 if that were the case. This is blue because of this 2x2 area. So this 2x2 area also means this 2x2 area is all blue, so this needs a green. So this is a boundary. This cannot be switching from green to blue, and it can't do that for yin-yang either, so therefore this is green-green. This is all blue, so this cannot be blue. This is green then. So this is a boundary here. This is all blue in this 2x2 area, so this is green. Because of that, you cannot have a diagonal green without essentially having a green here. Otherwise, you'd have a blue-blue. So these three are all green. So we have 1, 2, 3 segments, and 4, and this has to be 5. So this is 5 here, but we don't know if it's blue or green. So this is some combination of blue or green here. This blue must connect out, so this is blue. We have 3 greens here, so this can't be green. This is blue, and therefore is a boundary. This is 5. This cannot have 4 green cells, so this has to be blue. Right, because they would be the sum of equal to that digit, which is not allowed. So this has to be 6 through 9. We already kind of knew that it had to be 6 through 9, but anyways. This must be 1 through 6 at most. This can't be 1. This can't be 5. So if this is 1, 2, this would be 3, 4, and this would be... So 3 has to be one of these digits here. So this cannot be 3. If it's 1, 3, 4, this is 8. This is 8. You have 2 digits adding up to 8. It must be a 2, 6 pair then. So 2 has to be one of these 4 digits. We know 1 is one of these 2. This then cannot be 2 or 3. It's 4, 5, or 6, which means this can't be 4, 5, or 6 to add up to 9, because, or to add up to any other digit to add up to less than 9. This can't be 6 because this is at least 4. So it's 1, 2, and 4 at minimum here. Nine cannot be anywhere here. So 9 has to be one of these 2 digits here, which means this can't be 9 here. That means 9 has to be one of these 2 digits here. If this is 1, 3, this must add up to 8. So it cannot be 1, 7, 2, 3, 5. It has to be 2, 6. So either way, this is either 3, 4, or it's 2, 6 here. This is the same digit as that. It could be here. That's possible. One of these is 7, 8, or 9. We're not sure which. This cannot contain a 1. If this is blue, this has to be green going down that way. If this is green, that doesn't really tell us much. Anyways. This cannot be 1, 2, or 3, so we have 4 through 9. Obviously, 9 cannot be here. 5 can't be here because of this 5. This is either 7, 8, 9, or it's 2 blues added together, so this is 1 through 4. I think this is the same, right? It can't be 1. It has to be 2, 3, 4, if that's the case, to add up to 7, 8, 9. So 7, 8, 9, 2, 3, 4. So these two digits add up to each other, essentially. Either these two add up to this, or these two add up to this. This 5 eliminates 5 here. This 5 eliminates 5 here. Can this ever have a single digit here? If there is, it could be here. It cannot be here because then that would force a single digit here. So the single digit would have to be either here or here. And I think either one works. If you have a single digit here. Oh, that's interesting. Okay. If this were blue, this would have to be blue to continue this, because otherwise you'd have a cross of the blue and the green, and that's not allowed in yin yang. And therefore you'd have 4 blue cells adding up to a single cell, which is not allowed. Because we know, again, every line contains shaded and unshaded. So this cannot be blue, therefore this must be green. Since this is green, interesting. It could be 3 greens here, or what happens if these are 2 blues? If these are 2 blues, this is green. Therefore, it connects this way. There has to be a blue somewhere here. There could be, okay, blue cannot be just here. It could be here, and then this could be green. That is possible. This blue has to also connect to the red. Okay, so these are both blue. Since these are both blue, this must connect this way. So this is blue. Interesting. Okay, so either this is blue or this is green here. So we know this is a boundary. So this is blue. That means these add up to a single digit. It's either here or it's here. So this cannot be 1. The single digit is either here or here, so it cannot be 9. Can't be 5 either. So it could be 2, 3, 4, 5, 6. You can add up to at most 8. So this cannot be 2 here. Well, actually, no, hold up. It could be 2. Well, one of these is 2. The other one is 2 here. If this was the single digit here, this would be 7 or 8, which would require... Oh, this could be 1 in that scenario. Either way, these digits are 2 through 6. These digits are 2 through 6, which means we have a 2 through 6 quintuplet in column 4. So the rest of the digits have to be 1, 7, and 8. That eliminates 7 and 8 in the rest, 1, 7, 8 in the rest of box 5. So this cannot be 7, 8. This can't be 7, 8. This can't be 1. Therefore, these two adding up together must be a 4, 9 pair. So this is a 4, 9 pair, which eliminates 4 and 9 in the rest of the column. So this is 2, or the rest of the box. So this is 2, 3, 6, which means 6 cannot be either of these. Interesting. Right, because one of these has to be a single digit. So, and it cannot be 9. So since they can't be 9, this has to have at least, it cannot have a 1 because the 1 has to be here. So it's at least 2 and 6 at most with the highest digit. So these are then the digits 2 through 6. This is either 7 or 8 here, or it's 1, or this adds up with 1 here to add up to 7. So it would have to be 1, 6 or 1, 7 adding up to this digit here. Well, we know where's the 2 actually in row 4. It has to be one of these two digits. Because you can't have 2 and 7 adding up to a single digit here, because that would be 9. You can't have 2 and 1 because that would be 3, and that's not allowed. So the 2 has to be one of these two digits here. This can't be 2 because of the 2 here. One of these 3 is blue at least. Could be all 3 actually. Can it? Yeah, it could. If this is all blue, then this could be all green that way, right? This cannot be blue by itself, though. It could be green that way, and then blue, blue. And then blue. What are the remaining digits in box 1? We have 1, 2, 4, 5, 6, no 6. 1, 2, 4, 5, 7, 8, but this can't be 1 here or 1 here. Okay. This can't be 1. This could be 2, 3, and 4, though. That's fine. 2 is one of these 2 here. 6 is one of these digits here. 6 is one of these 4. This could be double green, though. Oh, Interesting. One of these digits, either this is 7 or 8 to add up to the other two digits, or this is 1 and 6 adding up to 7, or 1 and 7 adding up to 8. Either way, we require a 7 or 8 in one of these two cells. And this requires 7 or 8, and this requires 6, 7, or 8. So that eliminates 6, 7, or 8 in the rest of the column, of the row. So it must be 2, 3, 4, or 9, or 1. Right? This can't be 3 because of this 3. This can't be 6 because of this 6. That's interesting. Because this can't be 6, because of that 6, these two must add up to a minimum of 1 and 7, so that would be 8. And these two must add up to a minimum of 1 and 7, so this would be 8. So this must add up to 8 no matter what. So this is either 2, 6, or it's 3, 5 here. So this has to add up to 8. Because either this adds up to 8, which makes that an 8, or these two add up to 8, which makes that an 8. So if this is the single green, and this is 1, 7, this would then be 8, this would be 7. So this has to be 6 no matter what. So that's always 6. If this is 8 and this then becomes 7, which makes this 1 and makes this 7. That's the single green. If this is the single blue, this is 8 and this becomes a 1, 7 pair. So those are the possibilities there. So either way, 1 has to be one of these two digits. So this can never be 1. Okay. If this is 7, this becomes 1, 2, and 4. Which means this cannot be 3, 4. This becomes 2, 6, which means this is 8, and that works. If this is 8, this becomes 7, 1, 2, 3, 4. This has to be 5 to be with 1 and 2. So that would be 1 and 2. If this is 9, now that's the question, right? This is 2, 4, or 9. So one of these is a 1. This has to be 1, 3, 4, 5, 7, 8 as possibilities. Again, these can't be 8 because one of these two is an 8. If this is blue, this obviously has to be green. If this is green, though, this could be blue. We know one of these is blue, at least. It could be all 3? It's possible. These are both 1. Right? 1 cannot be here because we know there's a 1 here to add up to 6, 7, or 8 for 3 digits. So these can't be 1 because one of these is 1. These are 6, 7, 8, so one of these is 1, so this cannot be 1. Therefore, it's a 2, 3 pair because these have to be unique digits. Because you cannot have repeats on the same segment, therefore this is 4. This cannot be 4. This cannot be 4 and 3 then, adding up, so this must be 2 and 6 adding up, which means this can't be 1 and 2, it must be 1 and 3. So this 2, 6 eliminates 2, 6 here. This is a 3, 5 pair. This is 4, 2, and 3, adding up to 9. So this is 9. This can't be 9. This 1, 3 pair it makes this add up to 8. So this is 8. This is 8. This cannot be 4, 8. And this can't be 6 because of the 6, 9, 2, 6 pair in the box. This is 1 again. So 7 has to be one of these 2 digits here. 9 cannot be here. So this can't be 9 here. This has to be either 1, 8, cannot be 2, 7 because the 7 has to be here again. 3, 6, but it can't be 3, 6 because of the 3 in the column, or 4, 5. So if either this is 5 or 8, or this is 1 or 4 here to add it to 9. Oh, yeah, we already knew. Okay. This had to be 4 and 9 added together because 7 or 8 weren't there, right? So, and the 1 couldn't be there, so this couldn't be 5 and 1 adding up to 6. So we already knew that, actually. This was 9. Okay. Well, this is 7, and it can be with 2, 5, and 6. This can't be 6, though, because of this 6. 8 cannot be either of these, so this cannot have a 5 added to it. It's either 1, 3 or 1, 4 here. Where is the 5 in box 6? It cannot be here anymore, so it must be one of these 2, so this cannot be 5. We have a 1, 3, 1, 3 pair now in row 7, which eliminates 1 and 3 in the rest of the row. So this can't be 3. This is 2, which eliminates 2 here and 2 here. And this can't be 2 anymore, so this is 3, which makes this 6, which makes this 2. We still don't know what that is. 7, 5, 7, 9. So 5 has to be one of these 2 digits here in box 8. That eliminates 5 here, so this can't be 5. This becomes a 1, 4 pair, which makes this a 7. This 1, 4 pair eliminates 4 here, so this is 5, which means this can't be 5. This is a 3, 4 pair, adding up to 7. So this is 7, this is 7, this is 6, this is 8. This 7 eliminates 7 here, so that's 8. 8 can no longer be here, and 7 can no longer be here. We have a 2, 3, 4, 5 quadruplet in row 2, which eliminates 2, 3, 4, 5 in the rest of the row. So this must be a 6. That leaves these as 2 and 8, but 2 cannot be here because of the 2 here. So this is 8, which makes that a 2. This 3 eliminates 3 here. It's 1 and 3. This 1 eliminates 1 here. It's 4 and 1. That 4 eliminates 4 here. So this is 9, which makes this a 4. So these must add up together. So this must be the boundary here, which means this is green. We don't know if this is green or if it's blue right now. This is blue. This has to be a boundary here. This 9 eliminates 9 here, so this is 7. That 7 eliminates 7 here. This is 5. This is 9. This 7 eliminates 7 here, so it's 6, which makes this a 7. So this is 1 and 4 adding up with the 2 to add up to 7. So this is 1, this is 4, this 1 eliminates 1 here. It's 3, which means these can't be 3. This 4 eliminates 4 here. So this is 3 and 4. This can't be 5 or 4, so this is 3, which eliminates 3 here. It's 5, which makes that 3. This can't be 5, it's a 2-4 pair. That eliminates 2 and 4 in the rest of the box, so this is a 1, 5, 7 triplet. This 7 means this can't add up 1 and 7, so this has to be 8, and this is 1, and this is 7. So this must be separated by itself, so this is blue. It has to go here. This green must connect, so this is green. This cannot be 4 or 3, so this must be 2, which forces this to be 9. This 2 eliminates 2 here, so that's 4. This is 2. This can't be 9, and this can't be 8 or 7. And this is a 9. If this were a single digit, that would not work. This can't be a single digit because it can't be 9 either. So these two have to be part of the same set. So this is green. That forces this to be blue. And this can't be the same digit as that, so this must be the same set. So this is blue and this is blue. This set of blue means this has to be green because we have a 2x2 area, which is all blue right now. And this is the boundaries. This is 9, so only possibilities that add up to anything that add up to 9 cannot be 1 here. It has to be 5, 7. So this is 5, 7, which forces this to be 1. This must be 3 and 9 adding up to the 5 and 7. This is a 5, 8 pair here in box 7, which eliminates 5 and 8 in the rest of the box. So this can't be 5. This is 7. This can't be 5 or 7, so this is 6, which makes this 2, which makes that 6. This 2 eliminates 2 here, so this is 5, which makes that a 2. The rest of this is 1, 4, and 3. And this can't be 1, 3, 1 or 3 because of the 1, 3 in the column, so this is 4. That makes this 1 and 8 adding up to 9. This is 5. This has to be 3. This 5 eliminates 5 here, so that's 7. This is 5. This has to be 8 because of what's left. This 7 eliminates 7 here, so this is 8. And this digit is a 5 because that's the only digit remaining. That makes this a 1, which makes that a 5. That leaves these digits as 1 and 4. 4 can't be here because of the 4 in the column, so this is 1, this is 4. And that leaves 6 and 7 here. This must be 6 because that's a 7, and therefore this is 7 there. Pretty cool, actually. I like the logic behind all of this. This was very interesting, right? And, you know, who knows if this is the actual shaded part or if this is the unshaded part, but we know that basically one region is here and the other region is here. So pretty cool, pretty cool. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.